Okay.
Yeah.
All right. So welcome everyone. Glad you're here. And this is a kind of like a informal live help desk kind of event where we can discuss your questions, your design dilemmas, your part choices, dilemmas, what have you, or even your initial purchase of an RC vehicle to convert over to autonomous and Arduino control. That's the whole goal of this project, is to convert a hopefully inexpensive vehicle to equip it, get it fully on board with an Arduino processor and for its control, and to add sensors and to even, if you so choose, enable it to be either remote control mode or autonomous mode. And so that's kind of the context here. And so I decided a few months ago is when I started, where I formally launched this project for the group. And since that time, I realized that I was probably structuring the flow of all this incorrectly. I was trying to put too much into any one session. I was trying to provide instruction, too much instruction, 1 month to the next. And so I decided to step back and par down the content, structure it where it's a progressive design from start to finish for this vehicle that we're working on. And so this is the officially starting next month in February is when we will officially launch the full session curriculum for this. And at the end of this meeting, I'll announce what that topic is. But this is as stated in the agenda on Meetup, is that this is a Q&A. I'm not going to provide formally any instruction or whatnot. This is a one-on-one or one-to-many sharing of helping you answer your questions, and make sure that you are matching the Arduino, the controller board, and whatnot that you have purchased or that you want to purchase to your vehicle that you have or that you want to purchase. So that's the idea. And so Terry shared before I started the recording on this that he likely has to step out early. And so uh, Terry, why don't we kind of give you front and center attention if you've got something that you want to share, if you've got questions, now that we all understand the context of this event today.
Sure. Um, let's see. I do have several Arduinos that I can use, but I'm basically I've been also working with uh, two different robots. Um, One Steve uses for teaching his classes to teenagers, and I'm having a lot of problem with getting that to actually drive straight, and even with feedback, stay driving straight. And that's not really Arduino based, and I realize this is centered on Arduino, but that's a problem I'm fighting with. And so I Chaz actually gave me one of Charles gave me one of his robots. That this is one of the ones that was from the, see if I can get it to focus.
Yeah, right.
Uh it's
Oh,
blurry. It's having
that looks like a parallax
it
product.
is. It's a parallax propeller
Right,
board, also not Arduino, but
right.
I'm trying a couple different things because I'm trying to basically understand motor control better.
Sure.
Um,
Yeah.
and I even replaced the motors on the other robot that I had because they were driving it like 1-to-4 ratio between each other. They were way off. And
Uh,
I thought one of them might be damaged, but I couldn't tell which one it would be for sure because it was so erratic that I just bought two brand new ones and replaced them, but I still have driving problems. So basically, I'm just basically hoping to follow along and to learn a little bit better about motor control, even with the Arduino, and I can make
Sure.
the
Yeah.
parallels to the
Right. In
other
fact,
robots.
that's going to be one of our stepping stone initial part of this series. We're going
Yeah,
to work on power for and how to program the Arduinos correctly with
yeah,
or without USB being attached. That's going to be more or less session number 1 next month. But then starting then the preceding months, we're going to get all into motor control and ultimately how to not overdrive, like you were just talking about, Terry,
yeah,
not overdrive one motor over the other because everything has to be, as you know, based on what it is that you've witnessed with your platform,
yeah,
is that things need to be tuned together for motor control so that you can drive straight. Or worse yet, that one motor, at least one motor, say out of four or two, ends up getting burnt out because it's being overdriven so much and it and everything is being wonked out with the platform that way as well.
yeah.
So that's something else that another characteristic that can happen with that.
Yeah, and I tried a number of different methods for compensating and controlling the wheels individually. And I also changed the caster on it because the original caster was too small. Then I added a furniture caster, which turns really freely 360 too freely. And then I
Mhm.
tried to rigidly lock it into a straight line, and it still didn't help. And I'm like, ah.
Mhm. Mhm.
So
Right.
there's a lot of little things that can affect driving straight.
Right.
And
Right.
you know, if the caster is moving too easily, then it can waggle, right? So when it
Right.
starts going the wrong direction, it just freely goes, okay, sure, let's go that way. I'm like, no,
Hell,
no, I don't want to. So
I don't want that.
yeah,
I want this away.
yeah. I really didn't anticipate just driving a straight line would be that
Yeah,
difficult.
that's right. Yeah.
Um, it's been a educational experience,
Right.
in
Right.
quotes. But anyway,
Yeah.
that's
No, that's
what I'm doing.
right. Okay.
But I do have some R3s and an at least two R4s that I could use for building a robot with
Okay.
that. But I didn't have separate an RC platform or separate motors at the moment to
Hmm.
combine with my Arduinos
Okay. Well,
compared to the pre-built platforms that I have. So
right.
that's where I'm sitting.
Right. Okay. So if I may give you just a little bit of advice here,
Sure.
it per se, say like to participate fully in this series that we're going to be launching, you
Yeah.
really don't necessarily have to have a standard to the RC marketplace platform. You don't per se necessarily have to have that. If
Okay.
you've got something like what you're describing, Terry,
Yeah.
that even if it's just a smaller frame platform, that if say differential drive or Ackerman steering centric control, either
Uh-huh.
one will work fine. It's just the idea that depending on the size and all that, the surfaces and the expectations for the drivability and really what you can do with the platform can be different if we're not talking about an RC vehicle. But an RC vehicle gives us the reason why I wanted to focus there is number one, that in theory, the cost effectiveness is not as expensive to get started with a platform like that if you go on the inexpensive end for doing a purchase
Hmm.
versus something that is more robot hobbyist centric,
Yeah.
say like going with a Pololu platform. I mean, sure, there's smaller scale ones that are inexpensive too, but if we're getting a full fledged outdoor rover platform that is more robust and designed for robot hobbyists, then we're talking about an upscale in price.
Yeah.
That's not, this can be kind of cost prohibitive. And so that's why I wanted us to stay down on the RC standard type of way. So what I'm telling you is that you can go ahead if you want to use the platform that you've got. I would recommend, that's great that you've got so many choices for Arduino boards that you can play with, but you're probably going to want to get an Arduino Mega that has more I/O and memory capability than what an Uno, like an R3, can handle, and that's because of the number of circuits and sensors, whatnot, that eventually over time that we'll be adding for the robot.
Sure, no problem.
And
I can
so
get one of
that's
those.
so I would recommend that you consider something, so, the next generation or the next IO and memory layer or level
Yeah.
to the R3, and that is the Mega. And so I think you'll be a lot happier with that as far as memory and I/O. Okay.
Does a Mega have multiple memory configurations, or is there one particular standard config that would work?
Are you talking about memory models, or what are you referring to by memory configuration? I don't get
Uh,
you.
well, I mean, uh, Arduino, the lineup for Arduino, there's many, many different models.
Oh,
And
right.
so my question
Oh,
is it
okay.
a
Oh, I
Mega with
see.
a certain amount of memory that you're
Right.
thinking of?
Okay.
That
Right.
I'm
Okay.
just trying
So,
to get
okay.
specific.
Okay. Good question. Good clarifier. So I was referring to what's called the Mega 2560. All
Okay. Okay.
right. And so that's
Yeah.
a standard board that, I mean, is manufactured by many different vendors. But if you go with a Mega 2560, you're going to be a happy camper for the amount of memory that's available, the the extra bells and whistles that come with that microprocessor, as well as the many more I/O ports and configurations that can be done. So if you do a quick search, you'll easily find that.
Yeah, I see a number of them listed with an R3, Rev
Okay,
3
well, no, an
configuration
R3
is
is an Uno. An
no, no,
R3
no,
is an Uno.
no. This is
Oh,
listed as a Mega 2560 Rev 3, and they're
oh, okay.
abbreviating it R3 on some of the listings.
Oh, I
I
see.
realize there's an R3 Arduino as well,
Right.
yes.
Okay. All right.
Um,
Okay. All right.
but
Okay. Well, that. All right. Okay.
yeah,
Well, no, that should be fine then. That
okay,
just means that that's the third version.
yeah,
However, they're adding features and whatnot from the original. But so that would be the. So if to be thorough, to make sure that the R3 and stuff that you're looking at is a real comparison between the Uno and a Mega variant.
uh-huh,
Do a query on any one of the vendor pages between
yeah,
those two products and make
yeah.
sure that the one that I'm asking you to get is the higher memory count, is also the higher number of I/O ports versus the Uno R3. So that's the way to make sure that you're talking about apples to oranges here.
Okay, and most of these are listed with 16 megahertz clock. Is that
Uh-huh.
the typical standard?
Uh-huh. Yep.
Okay.
Mm-hmm.
Okay, perfect. Thank you.
Mm-hmm. Mm-hmm. Anything else, Terry?
Uh, no,
No.
not this time.
Okay. All right. Great. Glad I was able to help.
Thank you.
And hello there, John. Good to see you.
Hi there.
Hi
Sorry for
there.
being so late.
Oh well, it's okay.
I was
We'll we'll,
busy
we'll
working
dock
on
you.
my I
We'll
was
dock
busy
we'll
working
dock
on a
you some
robot.
way or
So
the other. We'll dock you some way or the other. But
okay.
you know what I mean. Uh, okay. So who would like to go next for? Oh, let's see. Actually, before I open the floor, I wanted to share something. A great tool that I ran across just within the last couple of weeks that I wanted to tell everyone about, that is applicable to Arduinos or really any other microprocessor that you want to build with. And the tool that I'm talking about is an AI circuit designer and parts researcher, and even PCB designer. If you want to have a board manufactured for your circuit design, it's kind of an all-in-one platform. It's all a web-based tool, and I'll put the URL into the chat. But what's great about it is that it's something similar to Fritzing. Fritzing is a Arduino board-based kind of visual circuit editor, and this is a tool that takes that to the next level. It provides AI functionality to research design options. It's kind of like Copilot or ChatGPT for circuit design, but it's much more succinct and gives you clear and accurate results that you can then include in your designs. It's really it's a great all-around product. So I wanted to talk about that briefly here. Sure. It's called circuitstudio.com. And what's great about this, let's see, I'm sorry, I'm trying to, circuitstudio.com. Yeah, one of the things I like about this is it's extremely cost sensitive. They have a generous free plan, and then their paid plans start at only $5 a month if you get a year's subscription. So we're talking about only $60 a year for a great circuit design, parts, and overall system design toolkit that is AI enabled. It's really I think a positive find for all of us. And then what's great too is it doesn't just cover Arduino microcontrollers; it covers Raspberry Pi or any of the other popular controllers that are out there, along with other boards that that we want to interface to or with. So anyway, I wanted to. Oh, okay. Doug says I got an error. Okay. Well, okay. Let's take a minute here, and I'll go over and find it.
Yeah, that's not working.
Okay.
I did find it in a general search.
Oh, okay.
If you need a paste in, I can also try to paste something in.
Okay. Yeah, go right ahead, Doug, and do that.
You gotta get to
maybe it's circuitdesigner.com.
Oh, no, I found Circuit Studio.
Okay.
But assuming this is the right one, I'll put it in and you try this one. Oh, I see. There's you have a typo in the way you spelled it originally is slightly different than mine.
Okay.
I don't know that that's a typo. That might have been intentional. There may be another one out there.
No, it wasn't intentional.
Yeah.
Sir, designer. Designer. Maybe it's circuitdesigner.com. No. Okay.
I put it in the chat. If you try that link and see if it's the one you're thinking of.
Okay.
Circuit Studio.
Embarrassing. Circuit Studio.
So they weren't quite as cutesy as you were. You tried to make it circuit, and it's circuit spelled as circuit.
Well, let's see. So, yeah.
Is that by Ultram?
Let's see. I'm sorry, guys. I sure can't. I should have made sure about the URL before we started.
You need a
Okay, here we go.
www.
Okay, here we go. It's app.circuitdesigner.com.
Uh-oh.
Okay, so I'm going to go ahead and put that URL into the chat.
Oh.
I put a www in front of.
Yeah, right. I know that. Yeah. Okay. Anyway, so that right there should be the correct product. That
that's different.
Circuitdesigner.com. Yeah, there's so many products that have similar names. We got to always be careful. what we're choosing here. Let me make sure. Yeah, okay, so this is the right product. If you go over to the pricing page or / membership off of that root URL, you'll see that hobby pricing at $5 a month. Anyway, it's really got great. Uh, it's a great sounding tool. I haven't signed up for anything yet, either paid or free. I haven't gotten around to that yet in my weekend plans. But yeah, I like I say, I just found it recently, and I wanted to let all of you know about it. And then I'm opening the floor for what you guys want to talk about.
So I've got some
Let's
stuff
see,
to show.
questions on this.
I got some stuff to show. Uh,
Okay.
let's see. It was what do they call it? Black Friday. Well, I usually just chill for Black Friday, but I was thinking about needing parts for this project, and so what I actually got is, I guess they call it Cyber Monday, which was December
Oh,
1st.
right. Right.
So, let's see if I can get this to show. Here we go.
Ah,
So I first of all, I went to Amazon, which was kind of, I ordered stuff from it before, and I wasn't that impressed with what I was seeing. So I went to Pololu, and I was very impressed by the amount of information that they provide.
I know.
Here's
I
my order came in this nice Pololu box,
oh yeah.
and I have just unboxed it actually. So I bought a lot of stuff because there was a lot of savings on that Cyber Monday. So I bought 5 of these
Well,
little PC or what do you call them?
yeah.
Proto
Proto boards.
proto boards. And I like the little form factor because well, they'll fit on a robot and you won't have to, worry about them sticking out the side. And these are particularly nice because they have screw holes down the middle. I don't know if I can get it to
Mm-hmm.
show.
Mm-hmm. Let's
Uh,
see. Actually, Doug, why don't you, if it's going to be easier for all of us if you disengage your blur on your virtual background. In other
yeah,
words, just put none for background
so I
off
did
of
not make
settings.
that choice, so I'm not sure where that even is.
Okay, well, if you go over to to settings off of more, or excuse me, I'm sorry, off of video.
Is it
If you
view up
click
there?
on if you click on your video icon at the bottom of your Zoom screen, and you click on
Here,
video settings, and then you can go over to appearance, or I'm sorry,
video.
off of video, and then appearance and virtual backgrounds or backgrounds, and then you can select none
Back
for the background from there.
and video, mirror my video. Blur. Okay, here's none. Okay, that's not terrible.
Mhm.
All right, so you can see the
Mhm.
here, adjust this a bit.
There, that's much nicer.
Yeah, and now you can see that unlike most of these proto boards, this one has a nice set of holes right down the middle.
Right,
So you could screw it down. Usually you're stuck with using double stick tape or something like that to mount.
exactly. Yep.
Then I got quite a few of these little modules. They're all in packages here. I just finished inventorying them this morning, and it came with a nice packing list that shows all the stuff. So I got let's see, some 5-volt step up, step down voltage regulators.
Mhm.
Um, those are switching regulators. Step up, step down means that you can either go up or down. I liked the power curves that these things had.
Yeah, I know. Yeah, yeah.
Uh,
Linear regulators are not the best solution at all.
right,
You want
but
to go with switch mode type regulators.
right, but these I compared them with the buck regulators, and I just like the features better. Uh,
Hmm.
and let's see, I got some single brush DC motor driver carriers, a couple different kinds of those, and some dual motor driver carriers. what I picked some different kinds because one of the things I'd like to do is um, figure out how it really works when you do PWM between um, 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 braking and powering versus open and power, right? If you do then they actually had some power curves in these write-ups for these components so that you could decide one of the things that looked like it made a big difference is how fast you can PWM. And so that's one of the things I didn't know yet is when you're working with an Arduino, it has a PWM built in to some extent, but you can only do it for a few ports, and then you end up bit banging for the rest of the ports. And so that would give us two different rates at which we would PWM. And so all of that would be interesting to play with.
Mm-hmm, mm-hmm.
And then I got some, let's see, FOV time of flight distance sensor.
Oh yeah.
Uh,
Yep.
the first one I got is a three channel, and so it shows three channels next to each other, aiming in slightly different directions. So it'll be interesting to see how that goes.
Mm-hmm.
And let's see. And then I got let's see, there's another. Oh yeah, time of flight. This other one is called it doesn't say. It's just got a big long name, but there's a slightly different distance sensor that I got. And
Mm-hmm.
then I got a couple of graphical OLED displays.
Oh yeah.
So that would be interesting to play with. And
What's the
then
size? What kind of sizing did you get on those OLEDs?
oh, they're a little bitty, but
Oh, those micro ones,
let me see what
or
it's
yeah. Anyway, super small.
128 by 64,
Yeah. Okay. Mm-hmm.
1.3 inches.
Mm-hmm. Yeah.
But it's
Yeah.
just black and white.
Mm-hmm.
And then I got a 6 degree of freedom gyro accelerometer and compass.
Okay. Right. Okay. Good. That's a good. Very good choice. Okay.
That's all in one order. So we'll see how all that stuff pans out. I haven't unwrapped any of them yet. So
Okay. Fun on the horizon, right?
yeah. So
That's
that's
great.
where I am.
So just one point of reference about Pololu. I love buying from Pololu as well.
Mhm.
Okay. Uh, and I agree. They've got copious code examples as well as great documentation at all levels. But one gripe that I've got with their documentation, the way that they put things together, is the main most all of their products come with a primary user manual that you can either view online on a web page or you can download as a PDF. But what I found with those user manuals is that they stuff a whole bunch of similar products in their similar in the same product line. The way that they've defined a product line, they put everything in together, and so it can be really hard sometimes to disseminate all that and just find the chunks that will apply to your individual part number. And so that is kind of a problem I find with the Pololu line. And that's something that you don't see, say, with Parallax or with a lot of the other robotic type vendors that we can buy from. And so that's something that's kind of a nasty on in my view.
Mhm.
So that's just something to be aware of. That when you're going through those documents, that you need to do a lot of parsing. Now, that's one thing, by the way, that AI can really help us with.
Uh,
Is you can specifically ask, disseminate everything from this main manual that is to do with XYZ part, and then it can automate that for you. But just something for all of us to be aware of with Pololu. Okay, so did you have any questions, Doug? As I know that you have, as John does, a RC platform that you've purchased. So do you feel like you've got everything equipped as far as the motor controller that goes with the motors that are on the platform, and it goes with the battery that's on the LiPo that came with it. What did you have any questions or points of concern going that direction?
So I'll have to go back to there were three motors on that thing.
Okay, right.
One for steering, one for the front wheels, and one for the back wheels. It doesn't have any differentials, which is probably good as a rock climber.
Uh-huh.
But it has a front motor and a back motor, which on the original platform were connected individually. Actually, I don't know that for sure. There were separate sockets, let's put it that way, on the
Uh-huh.
original circuit board for the front and back motors. They could just be hooked in parallel if I studied the circuit itself. But
Mhm.
I was going to try and put a separate motor driver for each of those motors. And that's kind of why I bought a bunch of individual motor controllers. But I also bought a couple of pairs. And we have a couple. Let's see. We intend to make more than one of these ultimately, I think. Um, and because you had us order two RC cars.
Two platforms, yeah.
I've also got another one that when I bought my original Arduino Mega kit, they had a deal. That was through Amazon. They had a deal to get a robot. So it's a little simple. I think it's probably also actually I don't remember if that one is um, um, with a what are we talking about? With a caster and left and right steering, or if it has Ackerman steering. I don't know. I'll have to look at that one.
Hmm.
I bought
Hmm.
enough stuff that I should be able to do all of those.
Yeah, I know you've got quite a arsenal of supplies. That's wonderful. It's wonderful. Okay. Let's see. So Terry, you've got your hand raised. Please go ahead.
Oh, yes. I just had a quick question. You referred to AI, and I was wondering because some AIs are groomed or tuned for specific content. Are there particular AIs that you're referring to when you mention AI that you've been using?
Okay. Yes. Okay. So good point. So first off, this circuitdesigner.com, I
Hmm.
think that is a great AI helper specific to research and confirmation of part numbers, circuit design for systems like what we're building here. That's why I have laser focused in on that particular AI tool,
Yeah.
as I already spoke of with that package. But in general, prior to my glue on of this circuit designer, I've been successfully and using the free platform. I have successfully been using chatgpt.com, just a regular boilerplate free account. Okay. And you've got to be like in general, of course, that as we all know, ChatGPT is a general purpose AI platform. It's not fine tuned into any one necessary area. Okay. And so, just granted with that, what I have learned over time in using it is that you have to be very, very careful. You have to be very specific. I'm sure that you do with Circuit Studio as well, or Circuit Designer, but you have to be very specific on what it is that you're asking for, what resources that you are providing, and you have to be, and you, as much of that preparatory information that you can give as the prompt or the input into these AI tools is what's going to produce the best outcome for you.
Mhm.
And outcome that where you don't have to keep going back and forth with it and rechurning everything and trying to get a new version of something, say because either of you got some kind of something off as far as a specific part or a different version of a board or something, which is very easy to do. So what I do specifically in ChatGPT is I go as part of what I do separately, like in a notepad document. I literally script out verbatim what it is that I'm going to copy and paste into the initial prompt, okay, in the tool. And so, as part of that descriptor and all that, I go and I find or I upload as external documents into the tool. I go off and I find URLs for all the different parts, etc., that comprise my request. And I specifically state in there, please use only these resources that I am providing. And then that way you're guaranteed, or at least more guaranteed, that the AI is going to use those references and not something else that it finds on the web. Because as we all know, say we're talking about this Arduino Mega or Arduino Mega 2560 and the idea between R1 and R3. Well, I know darn well that there are feature differences between those two boards. And so if you just blank out state in your prompt, hey, I want to use an Arduino Mega 2560, you can be darn sure that AI is going to utilize whatever it finds first, and not necessarily the variant that you yourself really want. So that's a cautionary point that I have found in using AI.
Yeah. I saw a recent demonstration of a gentleman using AI who doesn't have an electronics background, but he's very, very familiar with some aspects of coding and project management. And without any background in hardware, he used two different AIs to build both the code and the physical product of in a project, and he did it in the scope of about 2.5 hours. I watched the whole thing and I was really blown away. But he used Claude for
Mhm.
95% of his code, and when it got the code wrong, then he turned around and used Gemini to check Claude, and then fed the results back to Claude, and Claude corrected itself, confirmed and corrected itself, and he added a number of hardware items along the way. But unfortunately, in both those cases, he's paying for accounts on Claude. It's $20 to $100 a month on Claude, and then he's paying per token on Gemini. So
Mhm.
there can be a significant cost with the AI the way he was
Right.
using it, but he got 100% through the whole project working at the end with
Mhm.
multiple sensors and inputs. I was really impressed. I was like, wow,
Right.
that
Right.
is cool.
Yeah. Yeah. I know. I've seen videos. I watched a video, something similar to that, as far as the start to finish code, circuit design, all that
Yeah,
kind of YouTube video recently.
yeah.
And the AI that person used was Grok,
Oh,
Grok.
yeah, that's Musk's, I think.
Yes.
Yeah, right. Yeah, that's an Elon product. And so,
But
you know,
what I do want to point out that was really important, and he mentioned to me, is that different AIs. There's two different models, right, of how the AIs work. And I'm trying to think of it's like there's one kind and then everybody else. And I can't think of the name of what he said,
yeah,
but
yeah, see, yeah. So there's large language models, LLMs.
um, yeah, but he was talking about well, let's see if I can find it. I took notes on it, but the key piece I want to say is when you're the reason why he was using two different AIs is because they had two different ways they work. So when one makes a mistake and can't find its mistake because its methodology is different, the other
Hmm.
one did. And he
Hmm.
balanced them against each other. But if you pick two AIs that use the same methodology, you could go in circles,
Mm.
not realizing that neither one is going to solve your problem.
Right.
And I was trying to remember the name of it because one AI solves problems in a compact modular way and doesn't do a good job at system level. Now, I think that was Claude. And Claude couldn't catch a system level problem, but Gemini did. because
Mhm.
Gemini doesn't use the same functioning as Claude.
Right, right,
Um,
right, right,
and so he
right.
fed all of his code into Gemini to catch Claude's failure, and
Mhm,
then went back and
mhm.
fed it back into Claude. And then Claude recognized it and corrected it. But God, I wish I could remember the name of that. Claude, so
Uh,
there's a yeah. It's not LLM though. It's another
oh,
specific
okay. Okay.
of
Well, that makes sense what you were describing there. Yeah, I don't know what the terminology is either for what you were describing. If you could, Terry, if you could
yeah.
find that YouTube or training reference or project run through
Well,
for the
he's
video.
gonna be building a class at the makerspace to do this. It's not an it's not an open thing right now. Yeah, but he eventually is going to be offering classes in it at Snowco Makerspace.
Oh, I see. Okay. So in other words,
Yeah.
you didn't find what you were telling us about, you did not find, say, on YouTube or something else. It was
No,
more
it
of a
was a
private
direct.
interaction.
I came into the space to do something else, and he was working on it, and he said, "Do you want to see what I'm doing?" And I said,
Oh,
"Sure."
I see.
It ended up being 2.5 hours later, but it was fantastic because every problem he hit, he solved within 5 to 10 minutes. So he didn't waste any time at all with integrating his hardware and software. He was using um, an ESP32 to do a wireless controller interface to AI, audible interface. But he had a microphone, he had an OLED display. Um, he set up the serial communications, and he did all this by not writing one stitch of his own code.
Hmm.
That's what really blew me away. He didn't have to understand the electronics because he got it to tell him the pinouts and where to put the wires, everything.
Hmm.
And
Right. Right.
it was an impressive project because of
Right.
that. He deliberately did it that way because he wanted to show you can do this without having the knowledge that maybe an engineer does have,
Right.
um,
Well,
for
right.
beginners to learn how to
Right.
work with AI.
That's right. Okay, so let's see. Let me just make a couple of little quick points here. So
Sure.
I think again, I don't have any evaluation really critique yet to give on this circuit
Yeah.
designer.com tool.
Yeah.
But I suspect that a lot of these qualms for both code, circuit design, and system design overall can be solved literally in that circuitdesigner.com tool, and at an extremely cost-effective price. Okay, so that's one point that I wanted to make. Again, I don't have any proof of that yet. I haven't done any proof of concept work in it yet. That's one thing I want to do near term. The other thing I was going to comment about, and this is more or less a question for the way that fellow was demonstrating the merging and use of tools, overlap of tools. I have wanted to do that kind of thing too, because frequently with ChatGPT, I flag errors that is generating for me, or it's not providing sometimes enough information to really be able to build from what it's telling me. Okay. And I have wanted to kind of like export what the project space that I'm building in ChatGPT and then import that into another tool like Claude, like Gemini, whatever.
Yeah.
Um, but I don't know well that would how well that would work, and and exactly how you'd do that so that it's not a big headache with extra pricing. Because one of the things that's bad about ChatGPT is it gives you a spew, I mean, really a huge file. If you do an export of any individual chat in that tool, it's really a huge file that's
Oh,
generated.
yeah, I can clarify that. He ran out of memory space at one point, had to wipe all the memory, but at that point he was directing it to save all his code locally and comment his code too, by the way. It was inserting commentary into the code. And so he did that so that he could wipe the memory because he did run out of memory even with his paid subscription plan.
Oh, wow.
And it's agentic is what I was trying to remember. There are AIs that use the agentic model, and then there are everybody else.
Oh,
And
okay.
agentic works a specific way. But you're right that Circuit Designer may be fantastic because if it's specifically geared to electronics, then it has been fed all the right information
Exactly. Right.
without
Right.
having to rely on just the web. And Gemini is an LLM that does not use the agentic model.
Ah,
It's like there's a lot of them that are built on agentic, and then everybody else. So the everybody else I assume is sort of LLM models or some other variation, but they're
oh, I
not.
see.
Their classification is just not agentic. That's how
I
people are
see.
saying it.
Okay. I see.
Yeah.
Oh,
Um,
okay.
but anyway, yeah, and I should also say, to be fair, he developed two other tools he was using. One that was allowing him to give the AIs the same memory space to look at stuff with, and something else. So he had two software tools he was using that were needed to manage flipping back and forth between the AIs, but give them the same common base of information.
Ah, okay.
And so what he was, when I saw that, I was like, God, I never would have come up with those things, but he came up with them, and he's not really he's knowledgeable, but he wouldn't call himself a hardware programmer either. So
Mhm.
it was very interesting, but I think you would really get a lot out of seeing his class. But I don't know when he's going to have it ready, but he's working on it right now. So
Okay. So
I'll let you know.
can you tell us his name? That might be one clue in to be able
Um,
to find the information.
I only know his first name.
Okay.
It's Imran. I don't know his last name. Um,
They're pretty
but
distinct.
like I said, his intention is to have a class that can be taught to people that come to the makerspace, but also maybe in industry as well.
Hmm.
And so I don't know that he's going to publish it publicly if he's going to be selling it as a class.
Hmm.
Um, but he definitely would be publishing it through the makerspace, through
Hmm. Yeah.
another
It's
meetup
just,
class.
yeah, through
Right. Yeah. Yeah.
Makerspace. Okay.
Yeah, because that's part of his intent is he's hoping to draw in people who are interested in AI in the makerspace.
Right,
Um,
right. Okay,
yeah,
cool. Well, thank you
yeah,
so much for sharing that, Terry.
yeah. Sorry that was long, guys. I
Oh,
didn't mean
well,
it
I
to be
mean,
that long.
hopefully nobody got offended by that long conversation.
Yeah.
I just wanted to mention that I've done some stuff with Bing Copilot, and so far everything I've done has been free. Uh,
I'll be right back.
okay. When
Oh,
when
yeah.
when I when I use Bing Copilot, it will get to the point where it wants me to register or something like that, and I just make another window. Uh, and
Okay.
so and I can, you can just copy and paste from one to the next and keep it abreast of what you're trying to find out about.
Yeah.
I've had it write only a little bit of code so far, but it was in I knew that I wanted to use awk on a Linux system.
Ah,
Actually, I'm sorry, it was a BSD system. It was my Macintosh, and I knew that it was in there, but I had never played with it, and so it was able to direct me to how to open a console window and come up with the awk script that I needed to do the task that I wanted, and it took only a few minutes to get that thing to work, and I've been using that daily since.
yeah. Well,
The
what I thought was really kind of cool about what he did too is he initially told the AI the parts he was using and had it store all of the data sheets and stuff locally in the archive. So when he flipped to the other AI, all that stuff was available. Um, and he didn't even go out and research the data sheets for his parts.
Wow.
Um, and yet it worked out perfectly. I was really quite amazed. Um, but yeah, that's a gotcha. Donna's absolutely right that you can if it's searching the web, it can also get junk information in there that isn't accurate, that creates problems for you too, if you're not real specific.
Right. Right. And I'd sure love to know. I'm really interested to figure out how this person, Terry, that you were talking about through Snowco,
Yeah.
is, I mean, orchestrates that with the two utilizing the best features of at least two different AI platforms, and
Yeah.
then being able to store and reference stuff locally. I
Yeah.
don't logistically, I don't know how that works.
Yeah, that was the clever part that I think was kind of coming from his unique knowledge. He has been in the tech industry for a long time and actually worked for Microsoft for a significant period of time. I don't know if he's working now or if he's retired now or what exactly he's doing, but even though he doesn't call himself a programmer, and he's definitely not an engineer in a hardware sense, he's extremely bright. And I'm
Mhm.
I'm just like amazed at what he did, but he building the tools, the intermediate tools he needed, that part I don't know how he came up with that, but he even had it building a spreadsheet with the wiring on it, a wiring table for how to connect the ESP32 to his peripheral devices. So he was not looking up one single thing in a data sheet.
Wow.
Mhm.
He had the AI doing it and then telling
Mhm.
him where to put it. And it was freaking cool. I was just like, wow, you've thought of all the right pieces here, but I couldn't, those two intermediate tools, I couldn't duplicate that. I don't know how he came up with those for sure, but I'm sure that he would go into that when he's dealing with the class
Right,
because they
right.
were integral to what he was doing.
Right. Yeah. The only thing I can think of, that idea about and then I'm sorry, guys, and then we'll get off this topic, at least as far as from my comments are concerned, on AI. But the only thing I can think of for this local part,
Mhm.
that is the kind of the centerpiece of the exchange medium between the two different AI platforms,
Yeah.
is the idea of either building an Excel spreadsheet or a Word document, some other text editor or spreadsheet, what have you, program of going ahead and doing all your scope out for finding your electronic sources, or for and or even Visio, something like that. Because what's so nice about Visio, as a Microsoft tool, is that you can diagram in there, and you can also import PDFs and other reference documentation. So if you could build your local store of all your information and all of your input circuit diagrams that you come up with yourself for the
Yeah.
AIs to work with, if you could build all that into one file and then be able to point the AI platforms at any one time to that reference file.
Yeah.
And then I can see how you could have things locally and yet have two individual AI platforms using that same storage of information. So in theory, I suppose that could work.
Yeah, he had Claude collect the data sheet stuff, but then he was always directing it to store it locally and including the code and everything so that
Right. That's what it
he
is
had,
I'm talking about. If
yeah,
we, if you had a tool, something like Microsoft Visio, or, there's all sorts of tools like that now. But
yeah,
anyway, I'm sorry to
that's
digress,
okay.
but that's a very interesting, creative type topic, at least in my view. Thank you
Yeah,
for providing that.
yeah.
Sorry, guys. So I'll continue opening the floor. Or what's next?
I'm kind of interested in what Terry, I'm interested in knowing what his goal was. Was there like a specific thing he was building? Did he have parameters set aside for building something in specific?
Yeah, his intent was to build a wireless control interface to AI to be able to direct it um, to do projects like this. And he was using the ESP32 um, as his hardware base for it. And so he had the ESP32, he had a microphone input, he had a joystick also was included in that. And he got all those pieces working, including a visual display of the joystick working, and then he groomed the joystick for the jitter that it had. And then the AI actually created an app on the computer that showed him the joystick working as well as the joystick working on the OLED display. And what else did he have in there? I feel like I'm missing something, but
So
that's most of it. Yeah.
it was really kind of an exercise, an AI exercise then?
Yeah, it was an exercise in using AI without having the hardware technical details or writing any of the code by hand for the project. That he was able to go from beginning to end and build the entire thing and have it be working and documented by the time he was done, and have it all be locally stored, so it's not lost when you disconnect from the AI. It's not all sitting in AI memory space. He built his own intermediate memory space that the AIs could share on his local machine. And he was using a Macintosh computer, but I don't think this is Mac dependent either. The way that he was doing it, that's just happened to be what he was using. So his goal was to demonstrate being able to use AI when you have very little technical knowledge to be able to do a moderately technical project and get through all the hurdles. And I was impressed, and he did it step by step, pulling in each one of the peripherals. I'm getting the ESP32 to work and the serial communication to work, which there was a bug initially with that, and then getting the microphone to work, and then getting the OLED display to work and the joystick to work, and then demonstrating all of it work together
Mhm.
at the end. And it was a really slick demonstration. But he definitely had to do two special intermediate tools to make that happen. And one of them was building the spreadsheet, or it was using AI to build the spreadsheet, but there was a spreadsheet thing. I can't remember the name of that tool. And then he had another tool for the common memory space that he had too.
The spreadsheet that comes with the Mac is called Numbers.
No, it wasn't using numbers. It was building its own spreadsheet
Hmm.
on its own in a console window. I saw it. He was deliberately not using Excel or another common spreadsheet program to do it. He had the AI build the spreadsheet in this other tool. Yeah. And was feeding information into it. That was another thing I thought was rather amazing because I never imagined having it do that. As one of the things it was doing. But you're right, Numbers is on the Mac and Excel's on the PC, but he wasn't using Numbers. It was a console application that I was looking at.
Wow.
Yeah. Interesting. It was interesting. Anyway, yeah,
Mhm.
yeah. Sorry, but I digress. I'm taking this away from our specific topic, and I apologize.
Would you say that that he'd ever built let's see that he'd ever like programmed an ESP32 before?
No, I think this is the first time he's worked with ESP32s, and in fact, he started with one model and it didn't work, and he had to switch, and then he had the AI switch all the code from one hardware ESP32 to another one, and got through that hurdle in the very beginning.
Wow.
Yeah. But his whole intent was to demonstrate he didn't have the technical knowledge that one of us would probably have in this same regard. But he was a technical manager for Microsoft for many years on in certain projects.
Guys, I'm going to interrupt the flow of this AI conversation,
Yeah,
and if we, because we're already about halfway into our meeting time today.
yeah,
And so I want to make sure that we've got enough time for the on-topic questions and discussions that need to happen. So
fair
if
enough.
we've got time, we can certainly come back to this AI topic in a little bit. But let's go ahead and take care of the other questions and other points of concern on meeting topic. Okay. So please go ahead and open mic and share and ask questions.
So Terry, I was going to when you were talking about the make block robot that you got and you're using that, the controller on that thing actually inside the plastic module is a Mega 2560.
Oh, it is. Oh,
It is,
okay.
yeah.
Ah,
And it's, you can actually program that thing using Arduino C if you want to. You know, there's methods for doing that. The tools that the Make Block folks have on their website are primarily the building block, Scratch, essentially. Scratch 3.0 modified to fit their hardware. I've
yeah.
not.
Oh, sorry.
I haven't played around with the tracking. The motors, the drive motors on that thing have encoders built into them. And it seems like it should be possible to make it track straight. But then again, you need, you're talking about using some kind of feedback. You still need something that will give you a reference as far as, what are you using as a reference to get this thing to try to drive in a straight line? I mean,
Right. We were one of the guys that the president of the Makerspace, Terrence Tam, gave me some guidance because he's working with his boys in a first team.
Yeah.
Or it might be the level below first. I can't remember, but and he gave me some suggestions, and they were using block code, but the blocks that he had were different and they were better, and the blocks that are in this are kind of canned, and they don't always give you all the right information for the motor control. And in fact, when I went to the help files, there are none in there. When you go to help, it just says this is to be filled out later on everything. Then I looked up. I was like, ah. So they lack in their documentation. But I was using the modular Blockly prop code, and we were using the gyroscope for feedback. And he gave me suggestions on code to do that. But it only works for about 6 feet, and then it still starts having problems. And I don't get that. But it was making me wonder if there's something goofed up with the controller. Also, that compiler that, and I put this in quotes, the compiler or whatever that they're using, the Blockly prop, has a switch where you can switch to Python or you can switch to Arduino C or C code,
Yeah.
modified C, but it's broken on mine because I can't switch and see the code. I used to be able to, and it won't let me see it now. So I go to switch and it's blank. There's nothing there. So I can't see how it's doing it in the Arduino code to dig into it from the raw code side without building all my own code. And I wasn't trying to do that initially, but now I'm changing my mind. But I like the platform, but they made and I had to add some modules into it on the motor control, but they're still not as precise as some of these other ones that were designed for this other robotic platform that Terrence was using. I think it was a Lego platform. And that's a problem because their mod blocks actually you can use directly. You know what I mean? Like you've got control over the speed of the motors, the power and the speed in some cases, or the length of time they're running, or whether or not one motor is running or another. But sometimes you get only two, you're getting only one of the two things you need to give feedback. And so it's very frustrating how it's canned. Yeah. And it makes me wonder if they never really intended it to be driven in a precise way. And I was trying to use it to do the SRS build competitions, and I couldn't even get a straight line out of it. And I was just like, I was only trying to do the straight line and the square.
Oh, yeah.
So
Terry, when you were doing this testing with the compass, were you doing this indoors?
No, I wasn't using a compass. I was using a gyroscope.
Oh, the gyroscope.
If I
Okay.
said compass, I apologize. That's not what I meant.
Okay.
It was a gyroscope, and so, and then it was giving incremental feedback, and it, like I said, it works for about 6 feet, but that won't even meet the square build challenges to go 10 feet square, and I get to 6 feet and then start veering off severely, and I couldn't, no matter what I did to tweak it, it just would wander, and I couldn't get precise turns out of it either because of this. And I don't know, haven't solved it yet. But I would like to get it working on that robot only because I like a lot of other things about that robot.
Yeah.
And thank you for checking on the board, Steve, because I didn't realize that was a Mega 2560. I didn't dig into that. I mean, I haven't looked at that in a long, long time, so I didn't realize. So I even have one, Donna. I just can't make it
Yeah.
work.
So yeah. Okay. That's good. Yeah, that's good. It's just it's literally under the covers, so to speak.
Yes. Yeah.
Yeah.
And
So,
back to your IDE problem, Terry.
Yeah.
You may want to uninstall that package and then go back and reinstall it to
Yeah.
see if
I
there's some
really
sort
need
of
to.
a recoverable error
Yeah,
that
because in
can
the
be.
beginning I did switch back and forth, and I thought, oh, cool, I'll get to this later.
Yeah.
And
Right.
then I don't know how I
Yeah.
broke it, but I broke it.
Right. Right.
Yeah.
Anyways, that's just one idea to solve that problem.
Yeah. But yeah, I want to make sure other folks have a chance to talk. It seems like I've been talking a lot.
Doug H., you look like you've got a cool project that you're working on there. Would you like to talk on that a little bit?
Sure. Can you hear me?
yes.
Yes, we can. Uh-huh.
Yeah, so I've been kind of multitasking here during the meeting, listening to you all and trying to soak up as much knowledge as I can from the experts, and also eating. And then I've been working on my self-balancing robot, and I just got it working again. Let me give you a demonstration. So just see if it'll work here. Turn it on. It's got a little delay here before it boots up. Okay, there.
What sort of sensors are you using to balance?
Nice.
I've got a Adafruit accelerometer, gyroscope, and a magnetometer, and I'm doing the sensor fusion in software using the Mahoney algorithm. So it's all software based. And so I do basically I build an IMU, which is probably overkill for this type of robot, but I just wanted to build the IMU because I wanted to use it in other kinds of projects. Like I was thinking about trying to build like a VR headset or something like that to do headset, motion tracking, that type of thing. Uh, and so it works pretty well, not too bad.
Yeah, looks
Um,
impressive to me anyway.
Yeah, it needs a little bit of improvement. So this is based off the Zephyr real-time operating system.
Oh,
It's not Arduino
okay.
based or anything, but
Yeah.
yeah, I
Cool.
learned a lot from using Zephyr. I wrote some of the drivers for the sensors, the Zephyr
hmm
drivers, and
hmm
I actually found a bug in the Zephyr the GitHub code, just a real minor problem, and I made a contribution, made a Git pull request, and so now I'm a contributor to that
Excellent.
repo,
Yeah.
and so I had that
Congrats.
was pretty good. Yeah, thank you. Yeah. So
St-
any other questions?
yeah, Doug. So if you could, I know that you briefly stated for doing sensor fusion of the IMU, you briefly stated the algorithm, but could you put some details, please, into the chat
Sure.
for reference information? Because I know that's something that I want to study
Sure.
is sensor fusion, especially on the side of an IMU. If you could give some details, that would be
Yeah.
great. Because I
Let
know
me.
myself, again, this is a Pololu product. I have a couple of 9 degree of freedom IMUs. So we're talking about, the gyroscope. Anyway, the typical threesome that comprise an IMU. And I want to do to compensate for errors that can happen with any one of those three individual sensors that are grouped together in the IMU. You want to do sensor fusion to help, well, to fuse all those into one data set, but also to help compensate for errors. And so it'd be great if you could. Okay, so you got your repo up there. Okay.
Yeah, it's my repo. It has all the code in it. So this is my first Zephyr project, so it's probably, not ideal for learning, but it's, organized pretty well. It has, if you go into the app/source SRC directory, it has all the source code in it for doing the sensor fusion. And I just updated today while we're talking in the meeting. I just got it to work. So
Very impressive.
yeah, thanks. Well, it took a long time to put it together. I've been working on this for about a year and a half.
Yeah, I understand.
It's a crazy
I
amount
get
of
it.
time. So, but I feel like I'm getting better at it. So,
Yeah. Yeah. We all learn and grow with this hobby, and that's part of the fun of it.
yeah.
Did you have anything question wise, or if you wanted to, is kind of a direct ask, Doug, but if you wanted to participate in this RC vehicle conversion project, or conversion, or anyway, adding to some platform that you want to purchase, or another platform besides your balancing robot there, if you wanted to work on an Arduino project that is part of this whole series, did you have anything question-wise as far as purchasing of a platform, or microcontroller needs, or motor drivers, whatever, for such a project?
I'm still in the learning stage at this point, so I'm just trying to absorb as much information I can from you all talking, which is really great. Like the circuit designer thing, I wasn't aware of that. So I picked that up, and I pick up little bits of information here and there on sensors and all the things you talk about. So that's really helpful. Yeah, I'm not sure. I'm not sure what direction I'm going to go in next.
Okay.
It just tends to be kind of random direction. But if you have any ideas or suggestions, I'm definitely open
Well,
to.
so yeah, so as far as an idea or suggestion, to me, and again, this is, I think, a cost-effective next route for you, potentially, depending on what platform that you get, is this idea: if you do want to work with all the mechanical uh solutions already in place, a good robust platform, is to purchase an inexpensive remote control vehicle, either a truck or a car, and then convert, basically gut that with what comes on board with it, and then add in an Arduino or some other processor, but for this scope, an Arduino. And then that would be a great way to get you, and all of us that are going to be participating in this, great circuit design, system design, practicality experience, choices of sensors, and getting an entire system to work together. It's a great, I think, next step, even for you, with the sophistication that you've got for that balancing robot. If you're looking for a next step, even a parallel step, for next build, I would personally recommend that. Since you specifically asked for a recommendation,
Sure.
that's the way that I would go.
Okay, that's a good idea. Yeah, I'm not real sure. Thanks for that link to the robot controller, Aruga robot controller info.
Yeah, that's Terry, the kit that Terry was mentioning.
Okay.
That's actually on my Google Drive. I was just checking, and there's some broken links now on the MakeBlock website, and I was just looking to see if there was something could dig in there.
Oh,
But that
yeah, I
has
remember seeing the Origa reference, but I didn't realize that the Origa was a Mega 2560 underneath the hood.
yeah, that's what they chose to call it. So
Yeah.
that document has details about the sensors that they built into their little version of that thing, and so
Ah, thank you. I appreciate that.
sure.
Yeah, it's a make block Ranger configuration is what I'm using.
Hmm.
Right, the Ranger.
With
Well, no,
with
I'm sorry. It's a make block Ranger's the robot. I'm using the two-wheeled configuration.
yeah.
Yeah,
There's
because
three
there's three different
configurations you
builds.
can build. Yeah, you can build because they do have a balancer. That because this guy has a gyro and
Yeah,
rate sensor uh, built into that board as well. So there's a number of sensors. There's light, there's temperature, there's
yeah,
motor controllers, the LED ring. There's a couple of individual LEDs you can control, and
yeah, and sound output and sound
sound.
input.
Yep.
That's why I like it. Is it's got so many things built into it
Yeah,
that you can play with. That part's really fun.
that part. Yeah, but yeah, their documentation definitely could be better.
Yeah, because I tried to look up the encoders on the motors. Nothing. They don't.
Yeah,
They don't tell you, and well, they tell you a little bit, but not enough to tell you how what number you're actually getting back, whether it's an angle or a what do you call it? There's two different ways you get feedback from your encoders, if I remember right. And one of them is angle and speed, and I can't remember what the other one is. But they don't tell you that. They don't get specific enough, and it was frustrating for me because I couldn't put my finger on the key pieces that I needed to get really precise about what I was doing.
That sounds like a situation where I would try a chat bot like uh, uh,
That's a
basic
good point. I
Copilot,
really didn't try that.
because it can help you explore the documentation and find maybe documentation that you're not looking at.
yeah.
Good point. Thank you. I will put that in my notes.
Yeah, and not necessarily, you know, I know for myself, I only have to this day, I really only have experience with ChatGPT. But there's so many out there uh, that are generic versus topic specific. And so it's a good idea, I think, until you really find one that you really like, that you find is accurate for your domain that you're using it on. I think it is smart to try and just stay with a free plan, initially, and not get something paid.
Yeah.
Especially with the generic AIs. Something like this circuit designer, since that is our domain specific, I suspect that a paid plan is probably warranted there. But again, I don't have any proof of the validity of that statement yet. But that would be my take on generic versus domain specific AI.
Nope. Somebody, did we lose Steve? I don't think you realized he was still center point.
I'm in the background here.
Yeah, yeah.
Trying to got my pellet stove going back there. It's a little chilly down the basement here where I'm sitting, so I forgot about it. I was trying to start it up, but I forgot to turn the pellets on, so it just burned itself out. So reignited it. So I may get up and run back and forth, but I got you on a speaker here, so I can hear what you're talking about.
I'm wondering how John is doing with his robot, because I think he's further along than I am.
I actually have not done anything with that robot because I ended up starting another one.
Oh,
Um, Donna got me into the 3K sumo robot. So this one, I haven't worked on it. I've been working on the 3K lately. I could talk about that one. Um, I got
Is that a Pololu sumo robot?
no, this is all gonna be I don't know if I can see myself in this thing here.
Oh, yeah.
Oh, there it is. Okay.
Yeah, the like Donna was saying before, when you blur your background, it screws up the autofocus on the camera. So when you try to put stuff in front of it, it blurs out the item half the time.
yeah, he's got
So I've made some progress on it. Lately I've been trying to get my 3D printer working right. But
is that a wood base?
yeah, this one's just a temporary wood base that I had to get my I have a CNC router,
Wow.
and so I that's what I cut this out with.
Yeah.
And I had to I haven't used it in a while, so so it took me a while to get it going again, but
Yeah.
How do you make such square inboard corners with a CNC router?
ah yeah, I can't really see it from here, but I used a very small bit,
Oh,
and what it you have to do is design it so that it carves out a little bit more in that inside corner,
wow.
so that anything square will actually fit into it.
Right.
Otherwise, it'd be like trying to stick a square in a round hole kind of thing.
What are the rows of holes on the board underneath the motors? Yeah, what are those about?
It's just mounting the motors.
Is that a row of screws?
Yeah, yeah. It's just a row of screw holes. Yeah,
Huh?
yeah. And then it's just mounting the motors on there.
So those are countersunk then?
Um, no,
Oh, you thread from the top. They're wood
they're
screws.
just yeah, the screws. I don't know if you can see them there.
Yeah, it's a little hard to see what we're looking at. So yeah, they're you're just screwing into the wood with wood screws.
Yeah, yeah.
Okay.
At least for this one, for the wooden one, um, I will put threads in the metal one, but this is kind of like a prototype. So,
Did you plunge those holes with your CNC router?
mhm,
Oh,
yeah.
wow.
And it has little recesses here because it's going to hold the line sensors.
Hmm.
The line sensors inside this little notch there
Wow.
and on the back too. And then on the distance sensors on the three on the front, you can see those very well or not. They're
So
like,
you made the black part with a 3D printer?
yes, yeah.
Yeah.
And that's what I've been having problems with lately, is my 3D printer. Um, I hadn't printed anything that big before on the bed, this one printed just fine. And now it's like, then it started, switched to a different filament, and then all of a sudden it starts pulling up on the sides. It's getting a lot of stress pulling up around the outside. So made some changes there, but it's coming along.
So it sounds like you chose wood for your base just because you knew it was too big for your printer.
Oh,
Is that
no,
right?
I used the wood because I had it handy.
Huh?
Um, it'll eventually be aluminum, this buffer.
Wow. Oh, wow.
Yeah.
I think
Yeah,
that's neat, though. It would be fascinating to see an all-wood robot.
Nice little battery
hidden inside.
compartment. And so the battery has like a little spot there for it.
Ah,
I could probably show you. I did make a little page. I could probably share that. Let's see here. I have to bring it up first.
So one of the things you need to do for a 3 kilogram sumo is you want to get as close as you can to the weight, because if you're lighter, then you're lighter than your opponent. Uh, and so a wood base might not be the best because you want to keep your center of gravity as low as possible. And
Mm.
you end up adding weights to it. Maybe you could, drill holes and screw in weights from the bottom or something like that. But
Yeah, I
well,
have,
in fact, that statement holds true for mini sumo as well.
yeah,
You
exactly.
always, for sumo,
yeah.
especially for that contest type, you always want to maximize the weight for the class that you're entering.
And keep that with the low center of gravity. So it's
Yeah,
hard to get
yeah,
underneath your center of gravity.
exactly. Yeah.
And you probably want the weight to be as close as possible to the wheels so that
Mm.
like you don't want to put any weight on whatever it is. If you have two wheels and then something else sliding, you don't want your weight on the slider. You want them on the wheels.
yeah.
Mhm. Does that end up eating your battery more though by putting the weight close to the wheels?
Well, you want the weight. You got to have you want like I say, you want your weight to be as close as you can to the weight limit because you want to be as heavy as your opponent, but you want that weight to give you traction, and so
Yeah.
the place is as close as possible to the wheels, the
Okay.
driving wheels, not the like if you've got a caster or a
Right.
ball caster or a slider.
I got you.
Yeah, what I did with my other one, with my mini sumo is I, um, this space right here, there's a large block right there. I made that all out of brass. So it has a big brass chunk right below the motors to help hold those motors down. But another strategy that people use is adding, especially, well, only if you're using a magnetic uh, ring.
Mm.
The robot is running on a magnetic ring. I can insert some magnets in the bottom of this thing too. I could actually raise the weight of it to like, I don't know, probably quite a bit by using magnets.
Is that also to sense the edge of the ring? Are you using them kind of dual purpose or
Um,
with
the
the magnets?
the magnets,
Yeah.
no, it would just be the magnets would just be to um add a downward force so that you have more friction with the tires.
Oh, okay. As opposed to using like lead weights like they've got in the what are those wooden cars?
Yeah, the Pinewood Derby.
Pinewood Derby, yeah.
So yeah, with the magnets, if it's on a metal base, I could actually um, have
Oh,
a 3K sumo robot that provides like 6K of force if I actually, put the magnets in a good spot and everything.
And
interesting.
I hadn't thought of it before, but you could imagine using Hall effect sensors to sense the end of a magnetic ring. I'm not sure what all you'd need to do. You'd probably have to have a magnet and a Hall effect sensor in some sort of configuration at the edge of the robot, but you should be able to sense the end of the magnet of the metal plate.
Yeah, that's what I thought he was alluding to was a circular boundary on the ring that the robot could sense because it was metal. Is that allowed, Donna? Are there any limits to that? The material that the ring is made out of?
Uh, well, let's see. So first of all, I want to reference over on robothon.org. If
Yeah.
you go over to the contest rules and you click on the icon for sumo, there's just one set of rules that for both mini and 3 kilogram sumo. Okay. So let's reference that document there.
Yeah.
But as far as you're wondering about for ring material as far as the specs on that?
Well, yeah, I
Or
was thinking of if you made the boundary, the white boundary, metal or painted it white, but it was metal underneath so the robot could sense it based on a magnetic field as opposed to the white and black difference.
okay, well, let's see. So okay, so as far as SRS supplies that we use for contests, and also the way that the rules are written,
Yeah.
is that you can have, and this is up to any individual club is running these contests. And I'm talking about for either weight class. All right. Is that you can choose to only have a wooden or vinyl surface type of ring. In other words,
Oh,
no magnetic properties at all.
okay.
Okay, so we've got rings of both mini and 3 kilogram size that fit that criteria. We also have separate rings that are made out of steel. I think that they're made out of steel, so they're
Oh,
extremely heavy.
yeah.
Okay, and the idea is that that metal that is chosen, if I recall, for the official Japanese rule set that our rules are taken from, is that there is no specification as far as which metal type that that second category of ring is made from.
Yeah.
I don't think that's
It's
categorized
I think
undefined.
it does, I think
or
it does
mandated.
have,
But the idea is that you want to have a metal chosen that has magnetic properties, so that if you use electrically activated magnets, which is what John is referring to,
Yeah.
versus just static uh, magnets, okay, to add weight to the robot.
Yeah.
Anyway, so if you get electronic activated ones, then you want to have a magnet
Oh,
and metal pairing that will work, that will allow for that traction property to
then you'd
to
want
happen.
the whole
But it
thing's got to
seems
be steel, though, not the edge. I was thinking of a
right.
different
Well, anyway, so
application.
so what it is I was getting at, I diverted there for just a little bit. But the way that the SRS has our contest supplies set up is that we've got, again, for both categories, mini and 3 kilogram, we have separate, and across all these, there's the painted surfaces that is for the black, the white, and then the brown interior mark lines. All that is in the rules as far as that specification.
Yeah.
But that there is a separate per category metal ring, in our case, steel. Okay. And then that ring is literally placed, it's literally sat, so everything meshes together well. That metal ring literally sits on top of the wood ring, and then you've got a metal surface for the sumo rings. That's the way that we run it, and that's the way, as far as I know, throughout the world, the way that sumo contests are run for the ring materials.
I
So
think that application's a
so
lot
the
better.
totality of the metal ring is literally the entire surface.
Yeah.
That entire circular form is magnetized, both the white edge as well as the interior of the ring. Okay.
Yeah. That serves a better purpose in the competition than what I was thinking. So yeah, I see the benefit of the entire ring being steel, for the ability of the robot to have more grip too,
Mm-hmm,
with
mm-hmm.
electromagnets.
Right.
you wouldn't actually need electromagnets either. You could just use some of those other magnets as long as they're strategically placed and they're not
Right.
like the robot's not gonna um actually sink down and actually where the magnets touch the bed. It just has to be a little bit above the
Close. Yeah. So you end up getting, in one sense, you could say you get extra grip without extra weight by using
Yep.
the magnets.
Yep.
Uh, but in overall, it's the extra grip that is is a secondary advantage of the magnet. You want the weight to be as close to 3 kilograms, but in fact you make it behave as if it's heavier by having the magnetic grip as well,
Correct.
right? Okay. Interesting.
Yeah.
And then since the entire ring is steel, then if you had Hall effect sensors as they go over the edge, they should be able to sense
Oh,
that they're losing the magnet. But Hall effect sensors, I don't think you can't just have a Hall effect sensor and steel. You need to have a magnet in there too. So you might have a small magnet that provides the magnetic field that the Hall effect sensor uses to sense the metal.
I made a little metal detector with my grandson years ago. Um, it was a little kit
Mhm.
that that we put together. It just required a coil, but we could actually use it to find, detect metal in something.
Was there a magnet in there, or did they magnetize using the coil? That could be, yes, true. You
I
could
think it was just the coil. I don't think there was a magnet in there. No, it was
So the
just the coil.
coil then was powered and
mhm.
produced a magnetic field, which um, um, uh,
Interacted with
the
the
proximity
metal.
of the metal would
Yep.
change the inductance.
Yeah.
So
Yeah.
you'd be able to sense that.
Yeah.
Couldn't you also put a steel nail down the center of that coil and it would concentrate the magnetic field as well and make it stronger at the end
Uh,
for picking up objects? So
yeah.
it's basically electromagnet again, but it's
Yeah.
not a magnet core, it's a steel core.
Yeah. He found that really fun because my wife has some metal pins in her back from a surgery. So he was
Oh
able to
no.
find them.
Oh boy.
Future
He loves you.
bioengineer here.
Wow.
And just to clarify, the reason why I was suggesting for sumo design, the idea of magnet versus just static magnets,
Yeah.
is the idea that if you design it with electromagnets, especially if we're talking about a big 3 kilogram sumo robot,
Yeah.
is it's easier on the resources of the robot, namely the motors themselves, as well as battery consumption, power consumption. If you only activate in an electrical way the use of the magnet whenever you are being pushed. In other words, where that magnet is not always on, okay, in the
Yeah.
scenario that John was talking
Oh,
about,
that's
I can
interesting.
understand where it is that he's going with
Mhm.
that concept.
Mhm.
But in a way, it's harder on your motors, it's
Yeah.
harder on battery power that's required
Yeah.
over time with sumo runs if you've got your design that way versus the electrically activated and deactivated realm
Yeah.
of utilizing a magnet in the design. So that's
Mhm.
where it is that I was coming from on that
That's
concept.
interesting. So
Good point.
you're saying that even though the electromagnets do require power and thus there are a drain on the battery, if you only use them when you need to hunker down, basically, when you need to
Mhm.
Yeah.
avoid being pushed by the opponent,
Right.
then
Yeah.
that's still an advantage.
Yeah. She just meant that way you're not dragging the robot
Yeah.
all the time with a permanent magnet
Yeah.
and
Right.
burning up your battery and your motors.
Hmm.
90% of the time you don't need it.
That's
Right.
true. If you're trying to hunker down, you don't use your motors at all. So,
Right. Exactly. And you don't
so,
want to.
so the power that you would otherwise be using on your motors, just apply that to the electromagnet.
Now
Right.
the electromagnet when it comes on and it's going to pull the robot. I mean it's got downward force, right? Um, it, are there limits in the rules about the robot not contacting the deck though?
Yeah.
Oh,
It
Right.
really?
can't
Yeah. So I was
it
just
can't
going to
touch.
say that in the rules for both categories of sumo
Yeah.
is that there's a caveat there as far as magnetics. Well, as far as non-movability at any one time during an active match is
Hmm.
that if I recall, the rules state that you can only pause in place for a few seconds at a time. Otherwise, you are invalid. You have an invalid bot, and you're disqualified from that particular race.
Yeah, because if the robot
But
went down and touched the deck, it would almost lock it to the deck, and then
right,
you'd
yeah. So
always
there's so
not be
part so
pushed out.
part of the rules state that you can't damage the Dehoto. That's the name of the sumo ring. You can't do any damage to it.
Yeah.
And you also, if I recall, you can't, if you utilize magnets, the magnets cannot come in direct contact at all with the Dehoto at any one time, even when they are electrically energized. Now, again, that is, that's a subtle point, but if you've got an electronic design in place there, or even utilizing permanent magnets in isolation, those are important design decisions and things that you need to know about. Just as an FYI, guys, as far as sumo designs are concerned, John knows about this very well. There's a great book that is by a former that was written multiple years ago by a former member of the SRS. His name is Pete Miles, and he wrote a great book on all things robot sumo. In fact, it's called Robot Sumo, the Official Guide. And again, it's by Pete Miles. It's available on Amazon. Okay. And that book has a special section in one of the chapters that talks all about proper design to be a legal entry at all times for a sumo contest, in utilizing magnets across either mini or 3 kilogram sumo. So if you want to know all these details about when how to really utilize magnets or not in your design, that is always a go-to book. Thank you, Steve, for inclusion of that book URL.
Yeah.
So I could also mention about part of the project, the Sumo project, is I am including a remote control so I can actually start the robot from here instead of pushing a button on the robot, and I can stop it from here too. And it's using a little infrared receiver, one of those little tiny infrared receivers, and then it's sending that data. I have another a little Atmel chip here. So instead of actually using the microcontroller on my robot, I have a separate one that's getting that data from the remote control, and it's going to send a signal to the main controller, like an interrupt or something like that, that will start the routine or stop the robot kind of thing.
Is that just an old TV remote?
Yes, it is. Yeah. So I got this part working. So I got something working on this thing.
Woo-hoo-hoo.
And it's for actually stopping the robot. I added this little relay here.
Oh my.
And it'll actually activate at 3.3 volts and turn off the power to the motor driver. So that'll be my emergency stop thing.
Right. Yeah. Fail safe. Nice.
But anyway, that's the progress on it so far.
Does
Good job.
Does your microcontroller on your Sumo, does it know about whether the button is pushed, basically? Does it know whether there's power applied to the motor controller? Or is it?
I haven't got it going that far yet. But it will. I'll just connect it to like an interrupt and to actually, or probably doesn't even need to be an interrupt, because it'll be the start button. and the start, it'll just wait for that pin to go high, and then it'll start.
Right. Steve, are you building a new platform to go with this class, or?
Not yet. I we're I think we're going to be embarking in some changes to the SRS meetings coming up here, which we're hoping will encourage more active participation, and so I will probably try to do something along with that. We're you want me to share about what we're thinking, Donna? Does that sound good?
Oh, sure. Please go right ahead.
Okay. So we've had formal presentations for a bunch of years now of various professionals and teachers and professors and that sort of thing. But it feels like what we've gotten away from is the active participation in actually building robots. And so what we're going to do for our SRS meetings, which we might still from time to time have a presenter, but for the most part, what we want to try to do is we'll have a tutorial video that will allow us to learn things kind of like what you guys are learning here, and be able to apply these things to a specific robot building project, and with the goal of encouraging people to kind of walk along this common journey as part of the SRS meetings, which the way I see it, and some of you long timers have been around, try to kind of drive us back toward where we were many years ago, which was regularly building and demonstrating and contesting robots. And it feels like we've gotten more into it's become more of an observer kind of a experience, and we want to get back to a more experiential, participatory experience. So we're going to be starting that probably here in February. So
that's great. That's cool.
Yeah.
Although I appreciate the phenomenal speakers that you've gotten in the last several years have been amazing. But yeah, I think that's it's a good directional change a little bit to get people back to the roots of what we do.
Right. So
Cool.
yeah, and like I say, we'll still, and maybe we'll have people come in, do a shorter talk, so that there's time for this other thing. So we'll it's going to take a little bit of kind of experimentation to see how it goes. I mean, not having in-person meetings has made it more challenging to engage, so. Anyway, we've got some cool ideas coming down the pike. So I don't know if you got anything else to add, Donna. That's
No. Other than that, I compiled a list of a target starter list anyway, with some general suggestions on how to root out and find similar type of education videos to share during that segment that Steve was talking about every month. So I went through and I provided a bunch of my hit list favorites for that kind of stuff. Very similar to a lot of the stuff that I've shared directly in this group.
right.
And I think that people, I suspect, at least I have found them beneficial for education and reference information. So I think that being able to have a repository of good quality education content that provides not only inspiration but creativity to take what they've just learned, everyone who's at the SRS meetings monthly, and then be able to apply that to either to extend directly with what was shared during that content, or to apply it to something specific otherwise that the individual is building. To me, that is a great catalyst in moving all this forward, and that's why I suggested it to the committee.
Yeah. Our I think perhaps a kind of a good outcome from this that could be that people will get a taste during the SRS meetings, and then they will be inclined to come here and join this meeting to have a more extended time, a more specific focus for the entire time. So I think that we're hoping this whole thing will kind of synergistically work for the betterment of what the SRS does.
Yeah, it's worth a shot anyway. Yeah.
That's what I figure.
Did you get one of those robotic snowblowers I sent you the video of?
Was that fairly recently?
Yeah, I sent it recently.
I don't think I saw that one yet. Did you send that to me on LinkedIn?
No, I think I sent it directly to your SRS email.
Oh, okay. Okay.
Yeah.
Yeah, I haven't been in there for a little while, so I'll have to go check that out. Yeah.
Yeah, there's several different companies make different models now that are fully robotic snowblowers that are pretty slick.
Uh-oh. Oh, that's a doggy. Donna, I thought you were playing with some sort of a puppet, and then it.
No, it's my dog. She just had a wild zoomy type state going on there. So
yeah.
Well, this has been great, guys.
Yeah.
We're about time up, and as I promised at the beginning of this event today, I was going to formally announce the February start of this series. Okay. Event for this going to be next month. We're going to talk all about powering of your Arduino and programming it to get our robot prepared so that it can be a safe and stable platform for building. So that's going to be the focus. Platform architecture and power is going to be the topic for February. So again, we're going to talk about the ways to power your Arduino boards, USB versus battery versus some other method like a wall wart. We're going to talk about all that kind of stuff, and specifically the great ways, safe ways to program your board with or without hardware attached to them. In other words, like motors or what have you, sensors. And then the way to, so that programming step, and then disconnecting USB and then applying your battery power. So we're going to talk about all that kind of stuff for onboard use going forward. Again, it's kind of a proper setup type of topic for the build. Okay.
Yeah, I found with the Ranger that when I was doing coding for actual using the motors in motion, that I was having to plug and unplug the programming interface because it would power the board with the interface, but then it wouldn't run the motor code. When I went to test it, I had to unplug it and plug in the batteries, or it just flat out wouldn't let it run. It has some kind of safety
right.
control
and then,
on that, which is probably good, but it made it a little more tedious because I had to keep swapping back and forth to test my code.
Yeah, exactly. And then what's bad is if those safeties are not activated or what have you on your Arduino board, and you get something wrong,
you burn up
with
the
that,
output.
at that time of that switch,
Yeah.
or you've got dual power going to the board at any one time, depending on the way you got things wired up, is that you can end up blowing the board, literally destroying the board. So we want to get those kind of details hammered out and get a bulletproof recipe to use going forward. Okay.
Yeah. Cool.
All righty. Well, thanks, guys. This has been fun. Great seeing you guys anyway, and talking robotics.
Yeah. Thank you.
Anything
Thank
else
you
that somebody's got pressing that they want to contribute?
Terry, if you've got a few minutes to hang afterwards, I'd like to
Okay.
chat with you just you directly.
Oh, sure. Yeah.
Okay, so what I'll have to do then, because this is my own account.
Yeah.
So Steve, I guess I'll have to turn host control over to you.
Yeah, if you don't mind doing that.
Okay, let me see if host tools for participants. Okay, Steve, let's see here. Make host. Okay, so I just made you host, Steve. Yep.
Okay.
Okay.
Yep.
All
I
right,
see that.
so I'll let you go ahead and handle all of that. Okay.
Yeah, I'll shut her down when we're done.
Okay. All right, guys.
Thanks so much, Donna.
Thank you,
Yeah.
Donna.
Guys.
You bet. Always fun. I'm going to go ahead and stop the recording, by the way.
Okay, that's fine.